This is working with converting metric measures. Right now we're just going to look at how to quickly convert them by moving the decimal point or by multiplying or dividing. Later on we'll use what we call unit multipliers. For right now I'm going to be using some of the examples in the math workbook. The first is going to be on page 10. So page 10 of the workbook. So if you want to pause and get that out, you may do that. On page 10 for number 11, they have, for instance, G. For G, they have 3.21 decimeters. So we can see that decimeters is going to be the DM. Decameters will be the DA. They have the D and the A underlined under the deca there. But decimeters, and they want us to change that into meters. So we're moving from decimeters to meters, and we're moving one space. Since we're moving this direction, we are either going to divide or move a decimal point to the left. Since this one does have a decimal point, we can simply move it that way, which is the same way we moved here. So we're moved from the right to the left. So our decimal point now will be there, so our answer will be 3.321 meters. Okay. Next, we're going to go ahead and take a look at another one. We will look at J for J. We have 12, and the DA stands for the deca meters. And of course this M could be DAM for decameter, DAG for decagram, or DAL for liter. So we use the same prefixes for any of the different measures. Meter, of course, is for measure of length, gram is for weight, and then liter is going to be for capacity. So we're taking 12 decameters and we're changing that to meters. So we're going from decameters to meters. So we can say we're going to the right. So we're either going to multiply or move the decimal point. Now, if we're going to multiply, we're moving one space. Every time we move a space, it's times 10. So for instance, we can see here times 10, times 100, times 1,000. So here we moved it one place, it would be 10. If we moved it two places, it would be 100, three places, 1,000, 10,000, and so on. So we just moved it one place, so we can do 12 times 10, which is going to equal 120. So once again, we multiply when we move this direction. We can also take the 12. Any number has a decimal point that goes after the ones place. And since 2 is in the ones place, the decimal point just always goes at the end. And we move it one place to the right, just like we move this to the right. So move it there. And if we did that, if we had 1, 2 point and we moved it there, we would add the 0, which would give us our 120. Next, we're going to go ahead and look at N on page 10, 254 centimeters, and we want to change that into meters. So once again, we're starting with centimeters, which is here, and we're going to meters. So we're moving our decimal point this way, so either two places, so once again, 1, 2 places, or we can divide. So if we're going to move it two places, once again, we take 254, put the decimal point after the ones place, so always at the end if it doesn't have a decimal point. And we want to move it two places to the left. So it's going to go to there, so 2.54. So 2.54 meters for the answer. Now, since we're moving two places also, we could take 254 and divide it by 100. So this is 10 each space, so 10 times 10 is 100. So we could take 254 and we could divide that by 100. 100 would go in there twice, which gives me 200. Subtract 54. Once again, decimal point goes at the end, and it also goes in the answer. And then we can add a 0, because 254.0 is the same as 254, so we haven't changed the value. Then 100 goes into 545 times, so that gives me 500. Subtract, we get 40, and we can add another 0, and then 100 will go into 404 times. So 2.54, which was the same as our answer here. So we can either move the decimal point, or we can work with multiplying or dividing. Okay. Next, we're going to go ahead and take a look at page 12. On page 12, for instance, on 24A, we have 210, and that is DG, so that is going to be the decigrams. Remember, this would be DA, and we're changing that to grams. So we're moving from decigrams to grams. Grams is a base unit here. So decigrams to grams, we're moving one place to the left. So we can either, this way, we can either divide or just move a decimal point. Once again, if there is no decimal point, put one at the end. And we're moving one this direction, just like we're moving here, and our answer is going to have just the 21. So we're moving one place over. And then, of course, 210 divided by 10 equals our 21 grams. Okay, for another one on that page, and once again, this is just working with grams instead of with the meters. So if we go ahead and let's take a look at E. E is 12,800 milligrams, mg, so the M and then the G for gram, milligrams, and we want that to equal grams. So we're going to start with the milligrams, so we're starting here and we're going 3 places to there. So if we want to, we can either move the decimal point 3 places, or we can divide by 1,000. So if we move it 3 places, once again it goes at the end. 1, 2, 3 places. Our new decimal point will go there. So we would get 12 8/10 grams, or 12.8 grams. Now to divide, we're going to do, each of these steps is 10. So it's 10 times 10 times 10, which equals 1,000. One thing you could always do also is, since it has 3 places, it would have 3 zeros, so that would be 1,000. If we only moved 1 place, it would have 1 0, so a 10. So every place you move is going to be a 0. Okay. Let's go ahead now and take a look at something on page 15. On page 15, let's just look at 39A. So 39A has 1 liter. So they do a capital L so it doesn't look like a 1. 1 liter equals so many centiliters. So therefore we're starting with liters right here, that's our base unit, and we're going to centiliters. So we're going this direction. So we're either going to multiply or move our decimal point 2 places. So once again, 1 would have a decimal point at the end, move that decimal point 2 places, and we put in 2 zeros. So those 2 places, we add the 2 zeros. So if we're going to multiply, we're going to multiply something by 2 zeros, or by 100. So 1 times 100 equals 100. Either way, our answer is going to be 100 for this. Okay. Next, we can go ahead and look at B. B is 12 and 58 DL. So D is just going to be this one, deciliters. So the L, we're working with liters, and we want to go right to liters. So we're just going from deciliters to liters, one place this way, divide or move our decimal point one place. So 1.258. 1.258. Let's go ahead and look at another one. We will look at we'll go ahead and look at I. I is 147 centiliters, and we're going to make it into liters. So we're starting with centiliters and we're going to liters. So we're going two places to the left. So once again, no decimal point, so we can put a decimal point at the end. Move it two places to the left. 1, 2. It's going to be between the 1 and the 4. So 1.47. And once again, we can always, as we're going this direction, we can always divide by 100. 2 humps, so 2 zeros. 100. So 1.47 liters. Then we'll go ahead, do one last one. We will do L, which is 41 hectoliters to liters. So once again, we're starting with hectoliters. Hecto, think of the H for 100 hectoliters, and so we're going down to liters. So two places to the right. So our decimal point always goes at the end after the ones place, and then we're going to go two places to the right and add 2 zeros. So 4,100 liters. So once again, 2 humps, so 2 zeros, multiply it by 100, and we're going to have our answer. The students should be able to come up with this chart. We're, of course, always going to have the base in the middle, and the base is always just one whole one. So meter for length, gram for mass or weight, and liter for capacity. Then we have deca and deci, both meaning 10. So that's why it's 10 and 1/10. And of course, this is also divided by 10 because a fraction is a division problem. And of course, deca, like a decade, 10 years. Deca is like December, which used to be the 10th month, just like October used to be the 8th month. So these all deal with 10. Then we're going to have next centa. Centa is like a century, which is 100 years, or 100 cents in a dollar. Then we're going to have milla, which actually means the thousands. A lot of times we think it means million. It actually means 1,000. One of the ways to think of it is we have 1,000, then we have 10,000, then we have 100,000, then we have 1,000 thousands, which is a million. Also, with milla, these are all Latin based. Milla actually comes from 1,000, and one of the things we get our word mile from milla. Mill, because when the Romans would go for their 1,000-step march, basically, they would have 1 mile, which is 1,000. So they started out with the mile there. And then, of course, H for hecto and hundred, so that's one way to think of that. And then kilo means 1,000. Lots of times we see things like a 7K run for a 7,000 meter run. And one thing, of course, that you see now today also is, for instance, 2K16, which is 2016, which is our year. So K means 1,000. That's a way to help remember it. Okay. So that's one way to do it. We'll work with the actual conversion factors another time.